Och sen så ska vi vara här. Och så prövar jag och byter. Är det där den riktiga strömmen?
Ton of experience, but unfortunately I haven't been able to use Clojure in
Hände inte va?
F8 och F7, tryck dem fram och tillbaka.
Jag tyckte F8 nu.
Vad bra Peter att du fixar det.
Tack. Det hände inte va?
Nej. Fast du var på 2.
Jag var på 2, därför inte hände.
Gå till 1 där.
Yeah, I think it's really great.
Jag går till 7 till F7 nu.
Interesting projects going on with the Clojure.
Are you looking for people or is it
Yes.
interest?
Yeah.
So maybe we can share.
Fast den är det, varför? Gör så här. F7, F8.
Sounds very
Ja,
good.
nu det.
Ja.
De fungerar.
Ja, de fungerar.
Den är en bit efter bara, det kan vi försöka.
Nice coincidence.
Kolla, vad är din timer?
Ja?
Vad är din timer?
Säg en gång till.
Vad är din timer?
Min timer, okej.
Ja, det är en bit efter.
Det var bättre förut. Jag måste hämta mina kort.
Du måste sätta på era mickar också. Jag kan...
Probably, yeah. I read somewhere that the first language that you learn, that there's a special place in your brain where that language is, and the languages that you learn later, they are residing in some other place, so there's always some special place for the first language to learn.
It's like the cake stomach, special stomach for cake.
Probably, yeah. Similar to that, yeah.
I also, I moved to Sweden and there was this whole debate about a lot of the people I hang out with who were Finnish, they had this weird mix of languages. So so that seems also very detrimental. So it's better to get one leading with than another one. I like two good languages. It seems tricky and interesting.
Kreke, se vad är det på Twitter.
So what's
Well, I guess the big thing is that we're trying to expand our business mostly outside of Finland.
okay?
It's pretty like 60% of our revenues come from, or the turnover comes from outside of Finland. Yeah, I guess that's where we are looking for the growing our business.
There's some just an interesting development. I think there's a company in Finland, consulting firm that specializes solely on AI, which is very interesting because I think AI has been useful for specific problems for quite some time. But now it's becoming useful. It's almost a question of are there any environments that would not benefit from some kind of machine learning AI thing to optimize some flow. So it's I think it's pretty cool. And spoken with some companies, spoke to a company that started in Sweden that's trying to do a Finnish company pure consulting.
Den är ute va?
Ja, den är inte i...
Men jag är ute.
They started with trying to kill child but now they have this Agical AI. They have some progress that we
Yeah.
I think there's some stuff that's going to happen there.
Yeah.
I wonder how the exposure will fit that probably well, I would guess.
Yeah, I guess there's one project where we use the AI quite heavily.
You can talk about
I would plug it.
They're doing basically the security analysis so that
rehearsal.
the company has some...
Eller på rehearsal, eller? Ja. Du får störa honom. Du får störa honom.
Fram och tillbaka.
Ja.
Inte bråttom.
Men Ola ska vi kicka också.
So what they're trying to do is that they match them with the AI. And the AI give you overview of everything based on our understanding. These and these matching by these policies. And these and these policies that don't necessarily match. So it tries to reduce the work and the lawyers have to do to check this. that company, I know that there's a lot of good projects in there. Specializing in AI.
I don't think this company was Clojure really used
hardware to solve it.
I think the Swedish company is quite
It will be a learning experience.
becoming very successful
Open policy is
Yeah. Actually, I had my wife, she's a teacher, she's a second grade teacher, the teacher for the first and second grade. She tried like, give me training examples for the multiplication test for 5. She got the very good questions, how much is this multiplied by 5 and things like that.
usually what you see is
No, exactly. This is more fun.
Yeah.
Public was a huge
Something happening.
the answers were suitable for printing.
Yeah.
But then they made it or
Actually, too many.
if you had
30 cameras.
okay,
Then we said, okay, let's do it. Then was it
annat språk. Lego och datalog.
so Lady Gaga and you have a new part in the next year.
Yeah.
I asked it actually.
Yes. They are like fully since the pandemic. I think there was
Pretty interesting. If you want to realize
Have you found the beer?
Men är liksom när
I did not think they were
Tja! Det här vi kommer hålla ut så bra. Ja, bra att hänga av mig. Sjunka in lite.
Det är svårt här med Strömberg och hålla på också samtidigt.
Vinkar lite också. Vad sa du? Jag tror de är i köket.
Ja, det är bra.
Han
känns tillbaka på det.
Funkar det här i köket?
Känns tillbaka på det.
Har du lyssnat på om du... Vad är det för ljud där?
We have noticed that okay, there's quite a lot of growing pains that we actually have to start to act like a real company and having things like budgets and things like that. So I've been learning.
just a cool code.
Yeah. Unfortunately, somebody has to do some other things also. Yeah.
Yes, I recognize this problem.
I think there's like 24 of us. It seems that we grow to something like 20, 22 quite easily, but now it seems like it's more difficult to grow from this point on. And it seems that this is a quite interesting time.
Jag brukar börja med
One thing is getting talent in.
efter ett tag börjar det ta tid.
That's the most difficult, but also that once we have grown this much, it seems that we have to put some processes and things like that and make decisions. And when we make a decision, it seems that some people don't like it and some people like it. So there's also like some people have left, so that as fast as we are hiring new guys, the old guys are leaving. Yeah. get some hero business people into the company also, so that I could get back to the what I want to do and what I do best is programming. So yeah.
If you really love solving problems and you can solve creatively only a lot of stuff.
Yeah.
The mix can be okay, to me at least. But yeah, if you're just sitting in political meetings and stuff. Also, I don't think it's the best use of time.
Yeah. Yeah, I guess
Program right part.
that's I guess the biggest problem. And like everything I do other than programming, I have to learn it from the like there's a lot of learning and a lot of learning curve, and I realize that there are only people who know this stuff already, so it would be much smarter to take those people in and let me do the programming. Yeah.
Are you only looking for employees? Are you okay with contracts as well?
Okay with contracts because yeah, we use quite a lot of contractors also.
Yeah, because naturally I have everything set up and I have people who do it. It's all done. I just got rid of all employees and things. But for me it's very easy to do contracting work.
Yeah.
It's already there. Okay. I would love to work with Clojure. So, we can keep thinking.
Yeah, definitely. Yeah, yeah.
I think this thing was supposed to start.
ganska mycket, ungefär 50-50 mellan infrastruktur och ganska mycket också stora företag som har väldigt bättre järnvägar. Så de har någonting som ska göra, någon som skriver Clojure, någon som skriver Go, någon som skriver Python. Men just när det gäller typ identifiera applicering så vill man ha ett system. Varje team ska skriva applicering på sitt språk och så vill man göra en ändring. Senare måste man så det är ett sätt att unify. Policy. Det är organisation. Men det är kul, det är ett jättekul språk att jobba med.
Men då är det just att man har någon enhet som man hoppar och den enhetens implementation.
Exakt.
Det är det vi använder. Vi använder ett annat system som har fått ett brev till för att operera.
Ja, precis.
Även de som ställer ut biljetter och grejer.
Ja, precis. New Identity Server. Vi har jobbat med tidigare senaste 8 år. Där har man ju ett centralt system. Skillnaden här är ofta
Kommer strömmen att höra det en halv minut. Det blir riktigt bra. Nej, de hör den där hela minuten, eller hur? Nej, för det stod där. Ja, just det. Nej,
Jag är faktiskt från Västerberg.
alla ska få det.
Så igång, det var en minut.
Eller att den köper samma
Ljudet kommer.
Tänk inte på det så.
Alltså, autorisering är svårt. Det är svårt, särskilt i distribuerade system.
Varför?
Mutar du mig eller så?
Då är det lugnt, för det där fungerar med truppen.
Min utmaning är just i distribuerade system. Du vill ju ha allting så nära. Det betyder flytta ut allting. Men om du har liksom 3 gigabyte permission data så måste du ha varje beslut. Det är ganska svårt att hitta 100 baser. Det är problem att jobba med data. Distribuera data. Den delen är inte så rolig.
Hur kommer du hur gör du? Du här väntar du. Leker vi börjar tillsammans.
Jag vill ändå nöta. Jag frågar
På
faktiskt.
den tiden
Ja, tack för frågan. Jag vet inte precis.
utvecklare.
Jag bor på en lägenhet.
Du sagt att 9 någonting. Sen är det lite städning och sånt.
Jag vill faktiskt göra en...
Men när jag får loss den här så ska jag ha den.
your personal. I keep forgetting to bring kitchen knives to you. One of these times when we meet, I'll just produce a kitchen knife. Big one. Big one. No, I've got. I don't have any good knives. They're just like regular. I don't know. It's a knife with a wooden handle.
Yeah, sometimes they can be surprisingly good. Connection between price and quality is there, but it's also sometimes not there. But mostly if it's soft steel, then it comes down to more like how long it is. Okay, so we can keep it short. If you have very hard steel, then you can choose to go with a acute edge. If you do that with a softer steel, so like a few sides and then another one, and then you go with more dull, acute dull.
Obtuse, I think, right? Obtuse, is that right? Sounds right.
I go with that. If you have a knife used all the time, it doesn't have to be super sharp. So like if you're a chef or something, you come all the time and want to keep sharp. If you have hard steel, then you go become more it's more about that. The quality of the steel. Sometimes I was working at Clojure and a colleague brought a knife.
Yeah.
Well, like it took me so long time to and then he says, like, this was 2 years ago.
It's still sharp.
And of course he's not a chef, so you have it in the regular kitchen. Very different story.
Wow, is it really? 3 minutes from that time? Jeez.
Nej, jag sitter längst bak. Det är standard. Kan du gå? Det var glida. Ingen fråga. Jag vill svara på en fråga. Det kommer allt. Jag kommer på provet. Och så vidare.
Ska jag också trycka här eller? Nej, gör ingenting. Du bara skönt. Men det är ju liksom vilken... Nej, det går inte. Nej.
Men man har fortfarande det, men när du sätter på där
då kommer jag att höras.
När du gör det.
Ja.
They are here as well. Be afraid of being close. Yeah, so this will be streamed. But only the speakers will be streamed. So you will remain in anonymity if you like. With the Q&A, you can get your voice heard. Please keep your fingers crossed for the stream. It was the first time we do it, and it's surprisingly difficult.
kitchen knives. You have Japanese stones.
Yes, wet. Splash on stones.
Hello and welcome to Stockholm Clojure Meetup, hosted by Agical. Business in the center of Stockholm, in Gamla stan to be precise. We're going to have two presentations today. We're going to have Peter and then Josh. Peter is going to talk about give me interactive programming or give me death. Over to Peter.
Thank you, Ola. Ladies, gentlemen, wonderful to see you here. Tonight, I want to encourage you to ask yourself a question that I wish I had asked myself much more often. What makes work fun? I plan to do this by telling you a few stories of when I have had fun with software development, and a tiny bit of when I haven't. This is the way I want to work. I said this some 5 years ago, putting words on something that had started more as a feeling. I was enjoying being a product owner. I love product, and I felt done with my programming career. That I felt done with programming was a bit peculiar, though, because I have always liked it. Ever since I got my Commodore VIC-20 from my parents as a Christmas gift that year when I was about to turn 14. There were tons of fun games on the VIC-20. But not that I play them very much, because when you started the VIC-20, it showed the message, CBM Basic, 3,583 bytes free, ready. And under ready, there was a box, blinking, a cursor. This was a prompt. Via the prompt, this computer read what I typed, ran the instructions, which possibly printed something, and then showed me the prompt again. You might recognize this pattern. I will return to it. Ready, blinking cursor. I learned to code using my VIC-20 and its tiny handbook. This book dealt only with how to program the computer. This is page 2. Skriv detta program. Type this program. So, and that actually showed a bit complicated programs. I will make a easier one here. Like that. And what's more complicated with the first example here is that if you started the line typed with an integer, then nothing was printed.
But that machine down there, it's a C64. The 20s was only white. They came in white only. I know. I had them. And right now I have 3 C64s.
Tough audience.
So take like that. So the computer saved those lines in its memory. It was added to the program. You can picture this as the program with the capital P. The integer instructed the computer at which sequential slot in the program, this line should be entered at. And then if I typed run, pint, yeah. Let's show me something else. This is not just any crap REPL. This is actually a code editor, a line editor. So if I start what I type with a reuse and a line number, then that thing will be replaced in the program. Oh, it's hard to type here. Okay, let's try again. So like that. So the computer reads my input, evaluates it, prints things, and then loops back to me for results. For more input. So the start program of WIC20 is, of course, a REPL. Then, if I typed goto, followed by an integer, then the program was run from that line. So if I do go to 20, it will run that line. But this was not just from the prompt, it was also for the program, because run and goto were instructions in CBM Basic. So if I do 30 run, and then go to 10, you will see the most famous WIC20 program. Like that. And just to reiterate that this is a so this is the program, and we can then replace no. Okay, it stopped working. Let's go on. This emulator I haven't really different. Well, anyway, when I programmed the WIC20, I started with no program at all. And then I typed the program line by line, piece by piece, updating lines as I went, and the program emerged and mutated according to my will. I think Frederick Brooks must have used a system like this when he wrote, "The programmer, like the poet, works only slightly removed from pure thought stuff. He builds his castles in the air, from air, creating by exertion of the imagination." This is how it felt coding the WIC20. So I created games and utilities. The program me and my sister used the most was for practicing vocabulary. I wrote that one so that I could have more time to code. The feeling that I wanted to code my whole life was strong. My first job was as a programmer. I made programs that tabulated results from marketing research surveys, and programs that made diagrams from these tables. For a long time, I drew the diagrams using plotter printers. And we bought plotters that had HPGL as their control language. And then I used other programming languages for the logic. It could be shell scripts, awk, Perl, C, Tickle, you name it. In our printer room, there were 20-ish printers printing throughout the days, sometimes the nights too. Or I should say some plotters were printing. Plotters easily jammed, and they were generally suffering from lots of downtime, and they were slow. So it was very important for us to look for alternatives. There appeared a printer technology called thermotransfer, thermal transfer. Heat was used to stick color onto the paper, a bit like when you use an iron to glue a print on a t-shirt. These printers were much faster than the plotters. Some of them actually, unfortunately, not close enough to the real plotters. At some point, I bought a printer supporting another printer language named PostScript. The handbook had instructions for how to hook a terminal to the serial port of the printer and enter PostScript programs. And if I typed show page at the terminal, the printer printed the page. Wow, I felt a bolt of pleasant recognition from this. I bought 4 PostScript books. The RGB books from Adobe, and one named Thinking in PostScript. A PostScript program starts as a blank sheet of paper. And then it grows, piece by piece, function by function, into a whole program. My workflow was to type both in a text file and at the PostScript prompt. So I send the file as it was to the printer, and then I copied changes from the file and pasted them in the terminal. The code took shape in the file, and the program emerged in the printer. PostScript is an elegant and delightful language. I had thus far never coded anything that felt so fantastic. It was as if I was one with the printer, and that together we created whatever I could dream up. I really started to think in PostScript. And the PostScript REPL was many times more wonderful than even the VIC-20 REPL. I implemented a compliant enough HPGL in PostScript. This improved our throughput orders of magnitude. It also bought me time to rewrite all the diagramming logic in PostScript. Instead of using the other programming languages to create printer instructions, they now transform data shaped for the printer program. The result was pure magic. Our customers could suddenly start to wish for almost anything. There was something very robust with bringing it all down to data and then applying PostScript functions on this data. So now I had a workflow where I could grow the program that turned the data into business graphics in the printer. I always want to work like this. When the web became a thing, of course, I tagged along. At first, it was web interfaces for the diagramming engines and also for the data collection. Then totally other things. I worked full stack, and I wasn't picky with what programming languages I was to use. Java, C, Python, C#, Perl, PHP, JavaScript, Pike, Objective-C, C++, you name it, I used it. But my work programming wasn't as joyful anymore, for reasons I did not quite understand. In hindsight, I can see one of the reasons. I had been the one thinking up my castles, creating them out of thin air. Now other people did that thinking, and I coded their ideas. Work was now organized into people responsible for the product and people responsible for the technology. And as both a product and tech person, I was a bit torn apart. At some point, I quit programming for food and became a product owner. For 6 years, I did not question this, even though often I found myself coding, having a hard time putting some coding problem away. But that feeling of magic wasn't there. Maybe it was too different from 15, 20 years ago with PostScript. Come 2014, and I found myself part of starting a new kind of bank. Our architect, Linus Eriksson, had us take a bet on Clojure and ClojureScript. He and Ville Svärd, both from Agical, had a very interesting workflow. When I brought a suggestion to them, they could start with opening an empty buffer in Emacs. They typed some code into this buffer and sent it somewhere. And it returned with the results. They looked at the results, typed some more, sending it away again. And we discussed the results. They sent new code, returning us new results. After some turns of this, that thing we have been talking about emerged, modified by the feedback we had received. Sometimes the results was a prototype validating our thinking or showing us how we had been in error. Other times, the new behavior of our bank was implemented after such a session. I got so curious. My whole being tickled. Linus and Ville, they noticed this, and they often invited me to the programming table. Together we had fun at my attempts to force in my imperatives on Clojure. I was new to functional programming. But despite this friction, I felt it again. Strong. That sense. Overwhelmingly clear. This is how I want to work. Pure data, pure functions, and a REPL. And now I knew it was called a REPL. It connected me to the program, which emerged under my fingertips. I shifted back to being a programmer. And never again will I go astray from what I love to do. And never without a REPL. In the process, I created Calva for myself. Calva has a command for firing up a getting started REPL. It has now downloaded instructions, an introduction to Calva, as well as to Clojure, for me to interact with. You get the picture. At this point, the program is empty, save for some 200-300 standard functions that ship with Clojure. But if I evaluate this expression, it creates a new function. And if I change this expression and evaluate again, the program mutates. And so on and so forth. We build our castles out of thin air, from air and our imagination. This is what makes work fun for me. Thanks for listening. Yeah, I'm ready to take some questions, and Viggo here has a microphone for someone if...
What do you use for your slides?
Thank you for that question. So I use something called Joyride. Because you remember my first colleagues that showed me Clojure, they were using Emacs. And Emacs is fantastic. You can reconfigure it as it is running, throwing eLisp at it. it is this program that you can mutate as you work, and that is what Joyride is. So I don't think I have really the time to demo Joyride now, but I'd be happy to after Josh has talked to show you Joyride. I can tell you that I've been using it for this thing that I opened this page, and I've also used it for this timer that I forgot to start when I talk. So just since I used this for my slides, then it also makes sense to make it help me keep track of the time. So yeah, that's Joyride is making VS Code very much into some kind of Emacs, but with a much more nice programming language. So it's you should try it. Do I have any more questions?
Do you ever go back to PostScript?
Will I go back to PostScript?
Yes. Did you ever?
No, I never returned to PostScript as such. What happened was that Apple, or rather Next, choose PostScript as the display language for the next cube or the next OS. And so at some point I got hold of one of those, and then I had much faster feedback and runtime on them. But then I think this is when the web came, and it started to be not so interesting to produce these business graphics on paper. Well, then it was produced on screen and other technologies. So I had no reason to return to PostScript really. But it is, when I found Clojure, I realized that it's very, very similar to PostScript, even though there are no brackets in PostScript. So that's also, I think, goes to show that the brackets is not what makes a Lisp or a Clojure really. It is something else. But it's super dynamic and wonderful. I think that a new programming language for some other environment could actually jump off from PostScript, and people would love it. Yeah, we have another question there.
As new to the Clojure community, I'm finding it a big challenge, even though you have written the great Calva.
And the getting started repo.
But actually getting a project up and running, and because I've been programming for most of my life, I have an idea what I want to do.
Yeah.
So I'm finding it's a struggle to get where I want to be, just to start. And that's what I find the biggest hurdle in the Clojure. What's your suggestion to overcome this sort of, because when we are talking to other Clojure programmers, everything is so natural.
Yeah. You should keep talking to them, I think is my suggestion. So I can really recommend the Clojurian Slack.
Yeah, I'm there.
You're there?
Yeah. And I find it a great place.
Yeah, okay.
And it helps out, but it's still, you find it's kind of troublesome.
Yeah, of course. You will. I think there are a lot of like templates, programs you can start, depending on what it is you want to start with. There is a framework kind of thing that's called Kit. Used to be called, or it's a successor, I would say, to Luminous, and that will set stuff up, because often I think that in Clojure, since you pick and choose every like library thing, and there are no frameworks really, right? So this can make it hard to start. So then I think like an opinionated framework thing like Kit could help a lot. But if I will still just reiterate that the Clojurian Slack, if you're there, just ask. People are so friendly there and ready to help, because we are like desperate to bring in new Clojurians. And also this year, I am sponsored by ClojureScript together to focus on this getting started story more and getting it easier to get your first thing going. So hopefully, and I'm not the only one, so that's the focus of the whole Clojure Toolsmith community this year. So I think the story will improve also after this year, hopefully. Yeah, I think that I will stay here. You can ask me questions during the night, and I'd be happy to demo Joyride for you. And so I should actually get my ass out of here. Hello.
Hello, hello. Let's see if I do this right. Oh, look at that. Nice. Hello, everyone. Like the man said, my name is Josh. Since this is a Clojure talk, it's, I think, normal to start out with a Rich Hickey quote. So let me put one up on screen for you. Not sure which talk that's from exactly, but I'm sure Rich Hickey said it. So today, I'm going to get you into something called Blamda. And, oh, I need to press F2. Yep. Nice. Okay. So before I talk about Blamda, I should talk about what is Babashka, actually, other than the nice character on Peter's t-shirt there. What is AWS Lambda for folks who don't know? And then I'll talk about what Blamda is and who I am and some other stuff, apparently. So let's start out with Babashka. So Babashka is a fast Clojure scripting runtime. And if you want to know how fast, this fast. So on the top little laptop there, you have regular JVM Clojure. Adding 1+1, I didn't show the answer. I don't know why. But it takes it about 1 second to do that, which feels a bit long. Babashka, on the bottom here, does it in 2 milliseconds. So that is exactly like it says, a fast Clojure scripting runtime. It is meant kind of as a replacement for Bash for your normal scripting needs. So it has all sorts of awesome libraries for doing normal file system stuff, including starting other processes, messing around with JSON, and much, much more. It also bakes in the most commonly used Java classes, I should have said. So as a result of that, it supports a lot of popular Clojure libraries just out of the box. And Borkdude, who's the guy who wrote, the dude who wrote Babashka, is constantly submitting pull requests to make Clojure libraries work with Babashka that don't out of the box. If you have programs or Clojure libraries that just can't work for whatever reason, there's this pod protocol which fires up an external program, and then there's some kind of Ben code kind of protocol to talk to it. So it's also built with GraalVM, which is, I guess, interesting. That's just the way it gets to be native. And importantly for us, it is optionally statically linked. So we'll see why that is important in a minute. Okay, so AWS Lambda, according to the marketing tagline, it allows you to run code without thinking about servers or clusters, which feels like a good thing. It also has a so-called insert coin model for scaling. So you can scale either vertically by making your Lambda instances bigger and beefier, or you can scale horizontally because it's basically like an auto-scaling group in the container world. You can write functions in a bunch of different languages, including Java, Python, Node.js, .NET, Go, Ruby, or it turns out anything you want. Now, I'm going to pause on this slide to just give you a disclaimer. I enjoy Clojure. I have opinions about other programming languages. All of these programming languages are just fine. They're wonderful. They do things. I don't seriously dislike them or anyone who uses them. However, they don't speak to me in the way that that Clojure does. So please take this as a tongue-in-cheek homage to all the other great programming languages out there that are not Clojure. Okay, so let's talk about Blamda, finally, since that is what this talk is supposed to be about. So what it is it's a custom runtime for AWS Lambda that lets you write functions in Babashka, which I agree, that is pretty hot. Okay, so now that we've gotten through all of that stuff, let me talk about who I am. So that's a picture of me. I'm an engineering manager at a company called Pitch. We are a Berlin-based but remote-first startup, completely Clojure shop, ClojureScript on the front end, Clojure on the back end, and we make this wonderful presentation software that I am using right here. So just like Petter, I also wrote my own presentation software for this talk. So let me tell you the story of my life. So in 2005, well, I was born sometime before this, but in 2005, I ran into Scheme and understood that Lisp is actually a wonderful thing, not that thing they made me do in university that I didn't really like. But of course, Scheme, you can never use that for anything real. It's just an academic thing. 2008, I saw this this book called Programming Clojure, or Programming in Clojure, Pragmatic Programmers, and it was about a Lisp on the JVM. And I was like, oh, whoa, okay, JVM, that's a thing that I'm allowed to use at work. But it wasn't until 2012 that I actually did try using this at work. So there was, we had a need for a kind of inner system test framework, I guess. And I decided might as well write an enclosure, right? So following on from that, and a couple of years later, I wrote a game backend in Clojure and ran it on Elastic Beanstalk because that seemed like a cool thing to do. And in 2015, I moved to a local bank, and we needed to do some like data munging, like the usual thing, read some stuff from Kafka, bloop, and put it on S3, like everybody does that. So why don't we do this in Clojure and run it on EC2? And then a year after that, well, that worked so well. Why don't we write this ledger service in Clojure and run it on this thing called Lambda so that we don't have to worry about keeping our EC2s alive? By 2017, I had even forgotten what a container is. Lambda is so wonderful. So then the next thing up was we needed to write a really simple bank. And we decided why not run it in Clojure, why not write it in ClojureScript and then run it on Node, and then it'll be really fast on Lambda. And then we decided no, that's not the way to go for reasons that I'll get into. Okay, so we went back to JVM Clojure. The JVM Clojure is wonderful except for the cold starts, and I'm going to explain what that is and talk about that more deeply. So, you know, 5 years later, thanks to a generous vacation offer from my employer, I had a lot of time on my hands. So I figured that, you know, why don't I actually get into Clojure on Lambda and do things right this time? So, you know, confident is the word I used here. Naive could be another word. Foolish even, that would fit here. But let me talk to you about Clojure on Lambda, so the landscape for running Clojure programs on AWS Lambda. There are four very good options, and I'm going to go through them one at a time. So let's start with JVM Clojure, our best friend. So The good thing about JVM Clojure is that it's supported by the standard Java runtime on AWS Lambda, so that's awesome. There's a great REPL experience because you're in JVM Clojure, so you can use your standard REPL tools, Emacs, to interact with the program, as Petter put it so eloquently. Unfortunately, cold starts. Okay, so what a cold start is the first time you invoke a function, Lambda has to spin up a little micro container. Sorry that I said the C word. Pretend I didn't say that. It does a thing, and it runs, it starts the runtime, which in this case will be something that launches the JVM. And then in Clojure, now we have to initialize the Clojure runtime, and we have to evaluate our handler namespace, which sucks in all of the dependencies there and evaluates a bunch of code. Hello world on JVM Clojure like takes about 3 seconds on a cold start. You can get it down a little bit lower than that with some tricks, but that's about what you're looking at. Also, the AWS Lambda console has a built-in code editor, but you can't use that with JVM Clojure because your deployment artifacts are so big. And I think there's like a 3 or 5 megabyte limit on packages to be able to edit them in the code editor, which we'll see in a minute. So JVM Clojure sadly is right out. Well, moving on. How about ShadowCLJS? Well, the good news is, I should explain what ShadowCLJS is. It is like basically a build and packaging tool for ClojureScript, written by this German person, Thomas Heller, who's super nice and really helpful. But it's a way to get ClojureScript packaged up to run in the web browser or on Lambda, all of these things. Good news, it's supported by the Node.js runtime, the standard one. Great news, your cold starts are down now to, tens of milliseconds. Unfortunately, it's complicated to build. So if you've worked in the JavaScript ecosystem with NPM and Yarn and Webpack and all of this stuff, like it is just a very complicated place to be. So ShadowCLJS is amazing in that it like helps you do sensible things for ClojureScript, but it cannot, and in fact should not hide all of the underlying complexity from you. So it just, for me, like it's just too hard. I don't want to do this. You also have, okay, poor is maybe a poor choice of words, but in my opinion, the REPL experience for Node.js, ClojureScript rather on Node is not as good as the JVM Clojure one. Like weird things happen. Sometimes you have to restart your REPL, which to me is like, whoa, I've just lost the program, give me back my program. And because it's Node, you have this async programming model. And again, I just want to emphasize that if you're down with that, cool. For me, it doesn't work. Like I just want to execute things in a thread, and it's all good. Many threads, I should say. Okay, so Shadow, also no console editing because you're dealing with big deployment packages again. So Shadow doesn't work for me either. Okay, I'm halfway through my options. Holy Lambda. Holy Lambda is a really cool project that is focused around running Clojure on AWS Lambda. So unlike the previous two, which are like general purpose solutions, Holy Lambda is like, okay, I will make it easy for you to get Clojure on Lambdas. So it has 3 backends. One of them is regular JVM Clojure, though this person has done like a custom runtime that makes it a little bit faster, which is cool. The other runtime is a native one, so you can do a GraalVM compilation of your program. And the third one is Babashka, actually. So let's take a look at Holy Lambda, but let's pause a second for me to hydrate myself. All right. So Holy Lambda, it's simple to build. The build system is implemented actually in Babashka, so you just type like bb build or whatever, and stuff happens, and it's amazing. There's a great REPL experience because again, like this is Clojure we're talking about, so you can interact with it in a regular JVM Clojure REPL. The cold starts are really fast on native and Babashka runtimes. The JVM runtime still suffers from the same like slow cold start deal. You can also do console editing on the Babashka runtime anyway. You edit your Clojure code in a console, which for me is like the holy grail. Maybe I should explain that. Console editing is weird, right? Because you've already written your code. The console is not a REPL, so you're having this like terrible, slow feedback loop that we hate, which is why we use the REPL. However, as wonderful as your local experience is developing your Clojure program, once you deploy it into Lambda, something is inevitably going to go wrong. Like you have some IAM policy that doesn't give you permissions to do something, and having to redeploy your function, make changes, redeploy, make changes, redeploy, really sucks. So just being able to do that thing that we used to do when we like logged on to the web server and edited PHP right there, and like that is actually really cool. It's not as good as the REPL, but it's really cool. So I want that. Unfortunately, okay, for Holy Lambda, this was the deal breaker for me. It uses Docker, and I just don't want to. I run NixOS, and like Docker is not. Anyway, again, Docker is wonderful. If you're using it and it makes your life better, you are also wonderful. For me, I'm scared of Docker and I run away, and I just didn't want that in my Lambda experience. So, Holy Lambda doesn't work for me either. Okay, NBB. NBB is like Babashka, but it runs on Node.js. So this is also a Bork dude joint, if you will. And so my friend Ray wrote a nice little post on the Jux blog about how you can use NBB to do Lambdas. And I was like, oh, that's awesome, Ray. Let me check it out. So I checked it out. It's supported by the standard runtime. Awesome. It has fast cold starts because it's the Node runtime. It's also simple to build, and you can use any Node library. I don't know why I said Node, but yeah, anyway, any JavaScript library that runs on Node. You can also do console editing as long as your function has few enough dependencies that you don't fall over that, whatever it is, 3 or 5 megabyte limit. But it's still ClojureScript, so I still hate the REPL experience, and I still hate async programming. So, okay, I mean, I should have known the N in NBB stands for Node. It's not going to make me happy. I should have steered clear, but whatever. I'm a slow learner. Oh, Lord. Okay, so how am I going to run my Clojure on Lambda and be happy with my life? Well, okay, so there's this thing called Babashka. Right? I've heard of that. I've used it. I love it. So why don't I just build my own custom runtime for Babashka? Oh, this time I even used the word naive. Great. Yes, that is the correct word. I started this back in June, I think, or yeah, June-ish, July at the latest. And here I am. It's February. So that's a few months later. I haven't spent the whole time doing this. Don't worry, pitch, wherever you are. So let's talk about what I actually needed out of my Clojure on Lambda experience. And you may have intuited it through some of the reasons I discarded these other things, but let me spell it out like a good engineer. I want console editing. I want fast cold starts and low latency. I want things to be simple and easy. So if you haven't seen all the Clojure, simple means that each thing does its own thing and not other things. And easy means, yeah, it's easy to use or learn or whatever. So I want it to be both of those things. And I want my great REPL experience because, like you, I demand interactive programming or death, preferably the former, because death sounds less than ideal, to be honest. So, I'm going to take you along the same journey that I went on. Hopefully it won't take 6 months to do it, or wait, June, oh, that's more months than 6. Anyway, hopefully I can take you through this faster than it took me. But let's start by just talking about how Lambda itself works. So a Lambda custom runtime looks like this. You have the Lambda service out there on the left, which is handling all of the whatever Lambda-ing happens. And then inside the so-called execution environment, it sounds scary, but it isn't, you have a runtime API that basically just coordinates with the Lambda service itself and provides a REST-ish way of basically asking, like, give me the next function invocation and like, I'll deal with it and here's what happened. So if we zoom in on the execution environment then, this is what happens when a Lambda function is invoked. So first of all, you have the Lambda runtime itself making an HTTP call to the runtime API saying, give me the next event. This is a blocking call, and AWS are very clear that this should not time out. Don't ask me how I know that. The next thing that happens is the runtime API returns the event itself. This is all JSON stuff. So the Lambda runtime then invokes the handler in your code and says, like, here's the event I got. And your code does some stuff and things and says, okay, here's what I think of that event. And then the runtime sends it back to the runtime API, and we rinse and repeat. So that's the execution environment in a nutshell. So let's zoom in more now on the Lambda runtime itself. So let me talk about the life cycle of a Lambda instance. And now remember, a Lambda instance is the magical little black box of thingy that supports a Lambda function invocation. Container. All right. So first of all, your instance is created, and this is what I referred to before as a cold start. So it's firing up something, you know, some imp is running around plugging in cables or something, I don't know. Lambda now is going to invoke, the instance invokes a binary called bootstrap, which can be a script or it can be any valid Linux executable. The runtime now initializes, and what that means is that first it reads some settings from environment variables, such as like, where can I find your function handler? Where does your function code actually live? And where can I find this runtime API that I'm supposed to talk to? After doing that, it loads the handler file and executes any top-level code it might contain. So in our case, since we're talking about Clojure, it evaluates the namespace of your handler function and all of the stuff it pulls in. If there is an error doing this, it calls an initialization error API, and then now we're in the main event loop. So the runtime is going to ask, it's going to call the next invocation API to get that next event. It's going to wait for a response. It gets it back with some stuff and things. And then it invokes, not evokes, that's a different word, invokes the function handler with the event and something called a context, which I'm not going to talk about. It's just a map containing some metadata about the request and stuff. And finally, once the handler returns, it's going to call the invocation response API. And this is important and interesting. If the Lambda instance is idle for something around 15 minutes, it gets killed, and we have to start this whole process over again, so you get a new cold start. So that's why having cold starts be relatively cheap is important. All right. Moving right along, let's get into implementing our custom runtime. So this is an actual Blamda function, thank you. An actual Blamda handler that it just does a hello world, and there's some destructuring so you can pass in your own name instead of Blamda. And so right there you see, here is some Clojure code in a console. I can edit that, hurrah. So my first requirement is satisfied. I can do console editing. All right, but let's talk about where the runtime actually is. So in this previous one, this is just some code. What we do for the runtime is we package that up and deploy it as a so-called layer. So Lambda layers are ways to include other code alongside your function code. And the cool thing is that by putting the runtime in a layer, the runtime is something that almost never changes, right? Except when I fix a bug in Blamda, because, I mean, if it had bugs. So the runtime is not going to change frequently. So you don't want to have to deploy the whole runtime every time you make a change to your code. So this is the one of the downsides of JVM Clojure, because you're deploying an uberjar. So if you change one line of code, you're still deploying like what, a 20, 30 megabyte thing, right? So doing it this way, you have your runtime, which might be a 20 megabyte thing, but you only deploy it like once. And then when you deploy your function, you know, it's source code, so it's like what, 20 kilobytes instead of 20 megabytes. So that's fast. So here's what layers look like on the disk of the Lambda instance, because again, this is like a machine, a virtual machine, if you will, to invent some terminology. So your function code lives in var task, and I have included the function code there just to make it easy. And then your layers lived in opt, live, present tense, and opt. And the interesting thing to know about layers is that you can have many of them. I don't know how many, but at least two. And they get unzipped into opt on top of each other. So last one wins. So that's important to note. So it's just a flat unzip into opt. So what goes in a custom runtime? Well, I already mentioned the bootstrap thingy. So let's take a look at Blamda's actual bootstrap. Well, a simplified version. So this is a bash script. Even though Babashka is supposed to replace bash, sorry, this is a bash script. I could have done it with Babashka, but I didn't for my own reasons. I don't have to justify myself to y'all. So basically what's happening here is we are getting out of bash as quickly as we can, and we're starting Babashka. Here we go, Babashka time. So now we need BB here, right? Babashka BB is what the Babashka binary is called. So we need that in our custom runtime. So how do we get that? Well, we just download it from GitHub, right? Like everything. So I mentioned that it was statically linked. This is really important, right? Because I am dropping Babashka onto just a bare bones Amazon Linux 2 thingy, which is the Lambda instance. So I don't want dynamic linking to libraries that might not be there. So statically linked binaries are the way to go. So we download it. Okay. Now we have BB. Now there's this bootstrap Cloj. I pronounce .clj as Cloj. That's my choice. Live with it. And I realized when I was preparing this presentation, or rather when I was preparing for presenting this presentation, Bootstrap is a very poor name here, because what this really is a request handler. But anyway, I've called it Bootstrap Cloj. There it is. It's in the custom runtime. Let's peek in there and see what it does. So the initialization stage, and I talked about this on a previous slide, we read some environment variables to find out where the handler is and where the API is. Then we pull in the namespace by requiring it and then resolving the symbol. So now we have, congratulations, evaluated the handler namespace. To handle the events here, so this comment at the very top here, yeah, we set our timeout to like a day because like you really should not time out here. It messes up your runtime in a interesting to recover from way. So don't do it. Set your timeouts to a day, kids. You heard it from Uncle Josh. Okay, so basically the only thing that's happening here is we're just posting, we are doing a get to the next invocation API. We are invoking our handler somewhere in here. Where is it? Somewhere. Why am I not seeing where the handler is actually invoked? Oh, okay. Well, anyway, it happens. Sorry, I can't read my own code. Oh, by the way, I didn't write this code. I stole it from this Finnish person who also did a Babashka custom runtime for AWS Lambda, but also used Docker, so I couldn't. But I stole his code, so that's cool. Okay, so here's the actual event loop. Oh, right, sorry, that thing was a function that I was defining there. So yeah, you can see I'm calling next invocation. Here on line 60 is where I actually call the handler, and then I return it. All right. So let's talk about deploying this layer. I'll take a drink and you can just read all this stuff. It's amazing. Okay, so I am zipping up those 3 files that I said needed to be in my custom runtime, and then I'm doing a publish layer version command with the AWS command line interface. Hurrah. Okay, what we can do then, if we create a test event here, we can invoke this function with a name as Stockholm Cluj. And if we run this, first of all, the exciting thing to note here, is that we have a hello Stockholm Cluj in our response, so it worked. And then we have this deal here, some log output starting Babashka, blah, blah, blah. That is, that's a cold start. That's what's happening there. And if we look at the duration of this, 36 milliseconds, okay, that's not bad. It's not great, but it's just a cold start. So let's invoke it again. This time, all we see is the start stuff. So we haven't, like the runtime is already initialized, so it's not doing that again. Ooh, 1.56 milliseconds. Okay, that's normal. You know, that's slow for a web server, but it's fine for a Lambda function. So cool. Fast cold starts and low latency, right? So let's look at the simple and easy story. Okay. All of this stuff is simple. Like these are commands that do one thing, curl and zip and publish layer version. But is this really easy? I'll let the slide speak for itself. We can do better, folks. I'm happy to tell you, and we will. So let's take my little example that I had there, and let's structure it so that we have a bb.eden at the top, and we put our hello Cluj safely in a source folder. So the bb.eden, what we're going to do is introduce Blamda. So Blamda it's a custom runtime, yes, but it's also a little bit of machinery that makes it easy to work with this custom runtime. So we suck it in, and this is just the Babashka tasks framework. So we define a task called Blamda that then dispatches to Blamda, and we give it some configuration here. That's what that is. So by doing this, now we can type, instead of those other commands, we can type bb Blamda build all, and it does stuff. So it builds our custom runtime layer by downloading all of the stuff and stuffing all of the stuff in the zip file. It also creates a zip file for the Lambda, which I didn't show you previously, but you just stuff your source in a zip file, and that's your Lambda deployment artifact. And then, well, I like Terraform, so I included a little Terraform sugar for you, so you can write some Terraform config. And then you can say Terraform apply, and Terraform does the business. And now you have a Lambda out in the real world. So, okay, that was easy, right? You all agree with me? Now I've got simple and easy? Excellent. If you don't agree, don't worry, you're not on mic. Nobody hears you. Okay, but Hello World is awesome and also a little, I mean, we're serious programmers in this room, right? So let's get realistic. Let's do a thing where we invoke a Lambda function and it does some stuff to S3 because that sounds serious. So I have this S3 lister Lambda that I wrote. So by does things to S3, I mean I'm going to list some objects in the bucket. So you'll note here I have my top level bb.eden like I did before. In my source directory, I also have a second bb.eden. So anything inside the source, this is my Lambda. So the BB in there, the bb.eden in there is going to define the dependencies of my actual Lambda program itself. The top level bb.eden is only for like defining the Lambda configuration, the infrastructure as code type stuff. So this is the top level bb.eden. This is very similar to the one before. The only thing you'll note here is now I'm adding a couple of more config things, like an IAM role. This actually should be like some ARN : blah, 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 but I abbreviated it to fit on the slide. And then forgot to change it in my actual code, and my Lambda didn't work, and I was like, oh. But you know, defining an environment variable, which I ended up not using and forgot to remove. These things happen. And importantly, the two source files that I want Blamda to include in my Lambda deployment artifact. So that's the top level one. Now, zooming into the source directory. So my Lambda is going to need to talk to S3. So I'm going to use the Cognitect AWS client, and there's this thing called Oh Yeah API, which is the best name ever for a program. This is a port of the Cognitect AWS stuff to Babashka. So I think the tagline is Cognitect AWS plus Babashka. Oh yeah. So yeah, awesome. Now that we have done that stuff, we can fire up a REPL. So I'm in my source directory and I say bb REPL server. It sucks down some dependencies. Now I go back to Emacs and I do cider connect and woohoo, I'm connected. So now I can create an AWS client here and, an AWS client. I will introduce one of these rich components called, and I'll write some code in there. And these keystrokes are the easy to remember Emacs keystrokes for evaluating stuff. So this first one is evaluate, but please do not print because this is thousands of lines of Eden. So Emacs hates large buffers. That's just a thing you have to learn to live with, except in the latest Emacs, they fixed that. The second one here is, what is it? Evaluate previous S expression and print comment to buffer or something. It's got a great long name. It's fantastic. Okay, so now that I've actually got my, I'm listing my buckets. So what buckets do I have? Okay, I have a miscexample.com, hurrah. Let me actually list an object out of that bucket to see what the data looks like. So this is Clojure. Like, I don't want to read some API document to see what a thing looks like. Let me do it and look at the thing right in front of me with the real data. That's why we need REPLs. Okay, so given my experimentation in the REPL, now I can like copy and paste some stuff into functions. So here I have my client function. I have a function for listing the objects in the bucket and returning the contents. I have a function to sort by modification time, and I have another function to summarize these things. That's my S3 namespace. In my handler, what I need to do is I need to create the S3 client here, and then my handler expects you to pass me an event with bucket and prefix defined. Prefix is like the path to the object in S3. It's like if you call them files, that's the path. That's the way to think about it. So I'm going to call list objects. I'm going to sort them by mtime, and then I'm going to map them across or map them over summarize so that I get them down to a nice looking little thingy. So this is just me showing in the REPL. I can test my handler and stuff. I don't know if you can read that stuff. It doesn't matter. It's just Eden. It's just data, folks. All right, so I have now achieved a great REPL experience, right? All right, what else is there to talk about? I'm on slide 142 of 176, so I think I can wrap this up in 5 minutes. Sound good? Okay. All right, so let's talk about how this dependency stuff worked. So my real example had some dependencies, right? We got to get those dependencies to the Lambda instance somehow. So let's talk about how dependencies work in Clojure land. So first of all, you run the Clojure command. Clojure reads your deps.eden, which looks something like this. Okay, mine was called bb.eden, but whatever, they're the same thing. Clojure then downloads your dependencies to your local Maven repo. And if you're using Git libraries, which we are here, it will clone those as well. It will then build a class path. Okay, so class path is a Java thing. It tells Java where to find the jar files that contain your code and compiled, whatever that is, compiled stuff. Clojure then invokes the Java command with that class path, and your program runs, and everything is happy. So how does this work in Blamda land then? Okay, so you run this command, and I added the deps path there just to show you this is the default, so you don't actually have to do that. But you're saying, okay, Blamda, build me a layer for my dependencies, and my dependencies are in that file over there. And Blamda is like, cool. It reads this in, which looks like this. I don't know why I showed it again. Blamda now uses Clojure to build a class path, which has the happy side effect of downloading all your dependencies, like so. Running Clojure-s path is really cool. It just prints out the class path, so it doesn't actually run your program. So this is the class path. And Blamda then is going to stuff all of those dependencies into a zip file and make a layer out of it. Layer looks like this. Okay, here's the custom runtime layer. We don't care about that. We've talked about it. Here's the dependency layer containing all of the jars and stuff. And then the Blamda runtime runs BB with that class path. So this is the class path. So saying bb-cp feeds it a class path. So it says like, don't compute the class path yourself. Trust me, this is the class path you want. These are in fact the droids you're looking for. Okay, except when I do Clojure-s path, my home directory turns up in there, and that is in fact going to be a problem, right? Because I don't want to clone my home directory to the Lambda instance. So luckily it turns out by defining a local repo in your bb.eden or deps.eden, you can tell Clojure, like, no, I want my Maven stuff here, not wherever you want to put it. So this is some of the code of Blamda. So what it's doing is it's reading in your dependencies. It's adding that local repo key there. And you can read this code later. But what this is doing is actually replacing the base directory of the working directory where we are with /opt instead, right? Because /opt is where my stuff is actually going to end up. So once we've done that, we write that to a file that's important. And then we shove all of the dependencies we've downloaded, either Maven or Git stuff, into a zip file along with the file that we wrote the class path to. All right. So this stuff, this class path is only where I can find the Lambda code itself, var-task. But this, when I run it with the deps dealie that I just showed you or explained to you, that's a real class path there. That has all of the stuff that I actually need. So how does this work? Well, you see we have the class path, the deps class path file in opt because we put it in a layer. If it exists, we just cat it, and I realized that I'm not using the right bash thing. It should be $paren instead of backticks, sorry. And then we use that to start Babashka. And hurrah, everything is great. Your Lambda runs. We're all happy. And this is me proving it to you by configuring an event that provides a bucket and a prefix. And then this is the results. So I have listed some Lambda artifacts sorted by modification time. I hope I didn't actually read this, but let's just assume that they are. Okay, right. So how hard could it be, in fact? And with that, I'm done. Thank you so much for listening. I am happy to take any questions you might have, either now or in that room drinking beers. Or water, it doesn't matter. Any beverage of your choice. All right, no questions, perfect explanation. Let's go get some refreshments, and if you think up anything you want to ask me about, I will be available. Thank you again.
Thank you very much for tuning in and watching. Hope to be able to host again soon. And thanks you very much for showing up. And thank you very much, Josh and Peter.
Thank you. Thank you.
Yes.
There's a bunch of pitch stuff on the table. Support your local Clojure, well, not local.